we are looking at low carbon materials as a key transformative ingredient in the journey.
Products are made using this unique process, which is low carbon footprint, low pollution causing, low energy consuming.
What we do is we are working on recycling of plastics.
We have been in the business of bioplastics for the last 14 years.
A pleasant good morning, everyone. I'm Swarna Lakshmi and I work with EAI. I'm extremely glad to be a part of the ClimaFix Summit. We would like to request everyone to kindly make yourselves comfortable in your seats and keep your mobile phones in silent mode as we're going to begin the show. Let's start with our first module today. So it is the Star Startup presentations, where we have startups who have made an impactful impression in the climate tech domain. So the first theme for the session is based on low carbon mobility. I would like to request the following dignitaries to be present on stage. The first session for this is based on low carbon materials. I would like to request the following dignitaries to be present on stage. Mr. Sunil Cavale from Speciale Invest, Mr. Sivaram Pillai from Proklean, Mr. Sunder Balakrishnan from Natur-Tec, and Mr. Amit Tandon from Polycycl.
Wonderful. Good morning, everyone. Great to see you all here this morning at day 2 of ClimaFix. It was a great day yesterday, seeing a lot of people show up for the event, a lot of wonderful connections that were made. Thank you so much to Narsi and the ClimaFix team for bringing us all together once again this year, and looking forward to the future editions as well. Starting off this morning with a session on low carbon materials. In the process of decarbonization, I think a lot of emphasis has been laid on mitigating of emissions after the emissions have actually taken place, right? So we look at technologies that try to solve for it after industries have gone ahead and emitted in the form of carbon credits and so on. But a lot of work is also being done in decarbonizing the entire value chain, and that starts with looking at the products that go into the supply chain itself, the design processes, the production processes, and so on. And as an integral part of the decarbonization journey is the focus on the materials that are the building blocks of the entire process. And in that aspect, we are looking at low carbon materials as a key transformative ingredient in the journey. We have with us 3 startups today which are playing an active role in the journey, working on the plastic side of things, and Proklean also working on the detergent side of things. I will first request the startups to probably begin with a quick introduction of themselves in about 2 minutes, what you do, and then we will go ahead with the questions that you have chosen, and then probably have an engaging discussion where I have a few questions that I would love to ask you guys. So if you can introduce yourself one by one. Dr. Pillai, if you can begin, I think that'd be great.
So my name is Sivaram Pillai. I represent a company called Proklean. We are 11-year-old company, so probably no longer a startup, but been in the low carbon materials business for some time now. A quick introduction about us. We use a very unique fermentation process to produce compounds with or formulations with surfactant properties mainly, which replace chemical surfactants. But these products are made using this unique process, which is low carbon footprint, low pollution causing, low energy consuming, and made in a significantly lower cost capital facility. So maybe the slide quickly gives you a comparison between the kind of technology we use compared to the traditional fossil fuel based equivalents which we replace in the marketplace. So clearly the traditional approach to making specialty chemicals, starting from the fossil fuel building block, causes pollution, consumes a lot of water, is not very safe for the people involved in the production as well as the use of the products. Compare that to how we do it. We use a fermentation system which is carried out at ambient temperature, which means we don't heat or cool the fermenters. It is an non-aseptic facility. Typically fermentation happens in aseptic conditions. Because of a unique approach we take, there are no aseptic conditions to be prepared. And finally, there is no downstream purification step. At the end of the fermentation, the entire broth becomes the product. So those who are involved in fermentation industry know that about 60 to 80% of the cost of production actually is in downstream. So by eliminating the downstream, by eliminating the requirement of energy, we have a very low cost, comparatively low cost manufacturing system, because of which we are able to compete with the chemical equivalents we replace in the marketplace. So that's us. Currently we service leather processing, textile processing, and pulp and paper industry. We also have a small consumer cleaning range, which we launched about a couple of years ago. We are working on a couple of other areas which I will talk about when you ask me the questions. So thank you, that's me.
Yes, good morning everyone, and thanks to AI and Narsi to give us this platform to share our work. So my name is Amit Tandon. I come from, I representing Polycycl, which is a company based out of Chandigarh. What we do is, we are working on the recycling of plastics, and as you would quite well be aware that majority of plastics, in fact more than 80-90% of them actually globally end up being in the landfills. It essentially is a technology problem because we haven't really figured a good way to do anything useful at their end of life, or to convert them into some useful kind of downstream products which can serve society. So that's where our work comes in, and we are part of a sector which is now being called the advanced recycling or the chemical recycling sector. We are based out of Chandigarh. We started, and the early work goes back to about 2010, 2014, and then we have accelerated since then. We are a team of about 20 to 25 people, mostly scientists, engineers on process and petrochemical side. And I would be happy to share more about our work during today's discussion, including how the space of advanced recycling and work of companies like us can essentially provide a circular pathway to going from end-of-life plastics, which are presently an environmental scourge and are creating the numerous challenges we are all aware of, into a very useful resource that where the carbon inside them can be recaptured into building blocks or monomers for a host of useful downstream applications. Thank you.
Good morning, everyone. My name is Sunder Balakrishnan. First of all, thanks to Narsi for this opportunity. So I basically represent a company called Natur-Tec, and we are into bio-based and certified biodegradable and compostable plastics. This is a partnership with an American company called Northern Technologies International Corporation. We are a publicly listed company in the US, and we have been in the business of bioplastics for the last 14 years. Essentially, we look at alternates to conventional plastics. So typically, there are challenges associated in how do you manage responsibly a certain conventional plastic. And we work on different technologies which could be as simple as like a carry bag or a garbage bag, but going even to food service packaging like paper cups, coatings, straws. So any material which actually biodegrades in a certain managed infrastructure. And about me, I've been in this industry, I've been working for the last 18 years. Earlier, I was part of a company called Harita NTI, which used to be a part of the TVS group company. It was a company run by Mr. Venu Srinivasan personally, and have been working very closely on the advocacy side with the Ministry of Environment, pollution boards, CIPET in terms of testing, Niti Aayog in terms of policy creation, Bureau of Indian Standards in terms of standards creation. So I'm really very happy to first share and obviously learn a lot today. So thank you once again.
Gentlemen, thank you very much. I realized I'd not introduced myself. My name is Sunil Cavale. I'm a part of Speciale Invest. We are a deep science and a deep tech focused early stage venture capital fund, investing across hardware and software. We've invested across about 30 startups at this point of time with an active portfolio of about 25 startups across areas like space tech, EVs, robotics, batteries, semiconductors, green hydrogen, and more recently exploring the biotech and the life sciences space as well. The material side is of strong importance and relevance for us, and it's great to have these gentlemen here. Maybe I'd like to have one question maybe to Amit and Sunder as well, if you can both take turns helping us understand. When it comes to innovating on materials or recycling, creating waste, working on waste, there's always the prospect of converting the waste to something that is valuable, right? And that is where you need to find a market for similar products. How do you, as an entrepreneur, think about identifying those areas? Because you can use the waste input to create a number of products. As an entrepreneur, how do you identify those target areas which you think will find the most value for the products that you create? We'll go with the two gentlemen working on the plastics.
Yes, so for us, I think, especially lately, the last 2 or 3 years, I would say, there is just a bit of a positive serendipity, a kind of a favorable market situation. And that's because of the rise of the circular economy concept, which at a level of abstraction, it's really to keep the molecules that we are using in humanity in terms of various products that we are consuming in some kind of a continued motion. It could be a circular motion, it could be a next life, it could be a next couple of lives, but more than just for it to reach an end of life and lie then as a waste in a landfill or someplace. So for us, in terms of end markets, what happens is we take these low-grade, typically landfill-deflected plastics. Things to understand could be like these grocery bags and post-consumer streams like ketchup bottles having maybe residue materials inside them and bottle, all kinds of waste plastic streams being produced by households and by largely society at large. And most of these materials cannot or do not give themselves to an easy recycling using mechanical methods. We convert them to hydrocarbon feedstocks or hydrocarbon oils. They look and they have properties, physicochemical properties, which are a bit similar to diesel and naphtha. They would actually look fairly similar to the layman's eye, something of oils that are closer to diesel. Okay. And if you go back a couple of years, coming to your question, the end markets really would have been as fuel application, right? So they would have gone as industrial blend stocks to the markets. More recently, what has happened is, given the interest coming from petrochemical majors, petrochemicals are companies that manufacture these plastics, they see tremendous value in capturing these hydrocarbon oils as essentially building block feedstocks, which can be co-fed along with the incoming fossil chains that they have, supply chains that have coming in, and resulting in eventual production of plastics and many other kinds of sustainable chemicals, which are actually indistinguishable and therefore identical to those materials coming from the fossil route. So in some ways, it's a co-supplementation with the eventual hope of maybe in some forms of a substantive replacement of fossil extraction, crude, etc., for those supply chains to be replaced by keeping these molecules in motion. So for us in markets, in fact, carbon, just plastics or hydrocarbons, it's about 85% by weight, typically carbon. It's an extremely valuable molecule. As society, we do many downstream things with it. And the petrochemical and the oil and gas industry has pre-existing infrastructure where they can bring back these molecules to do a host of downstream things. So I think from the sector's standpoint, it's a bit of a favorable situation there.
See, the end application is really going to be dependent on what your waste stream is. For example, when we are looking at recycling, you have a physical recycling, which is if I take a plastic, I just take an example of a carry bag. If I convert it back into a granule, that's a physical recycling. Like what Amit was saying, if you're taking that plastic and depolymerizing it back to a fuel, that's a chemical recycling. And if you take that plastic and compost it with food waste and other organic waste, that's a biological recycling. So the application of what recycling is going to be dependent. For example, if I go for a food service product, where I already have certain food contaminated, like let's take the example of a McDonald's or a Burger King where you have so many plastics today being used, the most ideal end application would be composting because you already have food along with it. But then if you have a stream which would lend itself to a waste to energy kind of a system, then that could be the application that we should look at. So that's one approach. The second is also the geography of where you're doing it. In India, the dynamics could be very different from probably somewhere else in the world. And it's also related to the economics because finally it's the economics which drives every project. I mean, if there's no economics, then it's really not going to be sustainable. So in India, for example, I've seen that the whole rack picker model works really well. Where, for example, you don't see a lot of PET bottles on the road. It's because it's all being picked up and it has a certain value in the whole chain. But that same model would not work in, let's say, Europe. So it's dependent on the geography, the end application. You can kind of plug in whatever recycling technologies you want.
Very useful. Thank you. Dr. Pillai, maybe if we can go to the questions that are put up for you. Can somebody change the slides? Yes. Dr. Pillai, just in the interest of time, maybe if you can take one of these three questions and address them in detail as you would prefer. Yeah.
Okay. So I think I already gave a background about what we do. Maybe I can talk about the last question.
Yeah, I would be very curious about the last question. I would be very curious about the last question as well.
So we didn't start this company with a business plan. It was an enterprise which came out of two of us in our late 50s wanting to do something interesting for the rest of our lives. So the startup was not a way to earn a living. It was more to do our small bit to give back to the society. So when we started, the objective was to reduce pollution around us. That is where we started. It took us a long time before we could actually come up with products which could work in the marketplace. Almost 3 years. And then we had developed a platform technology using which we could make products which could service multiple industries. We started in the leather industry, then went on to textile processing, then pulp and paper, consumer cleaning products. Now we are working on a couple of other industry areas. The real wow moment came maybe 3 years ago when one of the applications which we commercialized was to prevent or reduce emission of H2S from an industrial unit. This was an industrial unit which was in the surrounded by villages. It was actually an expansion project which was executed with a lot of support from the Tamil Nadu government. But once it became functional, there was a lot of emission of hydrogen sulfide from the unit, because of which the people living around the facility had many health issues. So there were agitations. The collector of the district almost threatened the unit that they will shut it down. They had actually commissioned a chemical recovery process, but it was not very successful. It was not fully implemented, so they were having this problem. So we were approached, and using this unique microbial-based product and application process, we were able to significantly bring down the amount of H2S which was being emitted to such an extent that the villagers no longer felt the odor. It was not totally eliminated, but the purpose was that the villagers should live in harmony around the place, and we were able to achieve that. So that was a wow moment for us. Came after a long period of time, but kind of validated the reason why we started doing business.
Very interesting. Thank you so much, Dr. Pillai. With Amit,
Yeah, so
if we can take one of the questions that can somebody change the screen, please? Yeah. The next one.
yeah.
So maybe the scaling part of it, Amit, if we can
Perfect.
talk about that.
So is there a way we can pull up some of the slides? There are three
Can
or
we
four
pull up the
slides.
slides?
It just provides a
for
bit of a
Polycycl?
visual relief. So for us, essentially, the problem statement, I believe, is fairly well understood. Plastics came into mass production in 1950s. Over 7-8 billion tons of plastics have been manufactured since then. The industry continues to grow at a furious pace. Plastics are expected to actually double in production in another 20 years. Almost 90% of plastics ever manufactured have ended up in the environment and landfills, which dot all our cityscapes in different parts of the world. So inside that, that's really inside that landscape of a situation. When we look, essentially, there's also a deficit of a technology or a technological systems which will take these end-of-life plastics, convert them into something useful that hopefully has tremendous or a limitless offtake. So advanced recycling is taking a stab in that direction. So if the slides come up, I could show some of the photographs of the demonstration plant that we have up in Chandigarh. So in that, what we're doing in that plant, what we've done is our work is really about an architecture of a technology, which is an assembly of various kinds of different equipments, which take this landfill diverted polyolefins, which is a major category of plastics, and going through a thermochemical process, which means an application of a heat in a controlled, phased fashion. Essentially, you go from solid plastics to liquefy and moltenize them, and eventually you vaporize them in a certain controlled reaction to achieve essentially breaking of the long chain hydrocarbons that you have in plastics to much shorter chain hydrocarbons, which you eventually, when you will condense them in the right proper methodology, you get these kind of hydrocarbon oils or hydrocarbon distillates, which are physicochemically similar to diesel and naphtha and so on. So very valuable, I would say, premium commodity oils for the petrochemical industry and the oil and gas industry. So to Sunil's question before, a couple of years back, these oils actually have been going to as industrial blend stocks. A lot of industries using diesel, and they would essentially blend some of these oils with them and use in their combustion processes. So that becomes a next life solution. The real why it's finding the traction it's finding, why the spotlight is on the sector and the technologies, because of its ability that these oils can actually go back to the plastic manufacturer, the petrochemical plant, which are companies like BASF and SABIC and LyondellBasell and Dow and all of these big majors, Reliance and IOCL in India. And so they can accept it, and without making any substantive shifts or changes in their pre-existing infrastructure, they can leverage that infrastructure to go to a whole set of new stuff the key of which is actually plastics. So here we had plastics which were otherwise non-recyclable or considered non-recyclable or at least difficult to recycle, diverted from the landfills, coming back into the technology, into hydrocarbon feedstocks, which go back into the circularization framework. And it's not, can you do this 2 times or 3 times? You can actually do this endless number of times because this is a molecular transformation. You're going back to the building blocks. Sunil, to your question, essentially scale, the challenges of scale was when you go and when you're looking at putting an implementation plant on the ground, you realize there are other parts of the jigsaw that needs to come together and not just the transformation or the conversion aspect. And one of that is actually a bit of a technology plus a business model question. When you're putting plants, these are plants which have lives of upward of 20 years, okay, as similar to like small petchem refineries. And when you're going to put these plants on the ground, how do you have this contractually secure, cost non-volatile, or at least cost predictable supply of the kind of plastics that the conversion system accepts, which is polyolefins, HDP, LDP, polypropylene, the largest variety of plastics we are consuming. How do you do that, right? And I mean, who's going to be on the input side of the feedstock who will essentially ensure the quality of these materials that you require for the conversion process and will provide to you on a secure basis. So our work has been that when we scouted the market, actually at scale there's no one, right? So, and that is why this has been largely a bit of a small and a cottage industry priorly, because at scale you will not find companies who can deliver the post-consumer streams, which is the municipal streams, extract these materials from municipal streams. So we have actually, for us, there was no choice, and also to a lot of benefit in terms of building know-how, we actually stepped into that direction, worked with various waste management companies, including a company called Ramkey. Some of you may know of them. They've recently branded as Resustainability. So we have now spawned a joint venture where across different cities and cityscapes in India, they have access to feedstock. They are a waste management major. And the companies are going to work together in joint venture and segregate out these polyolefins, which will then come for the chemical recycling or the conversion aspect. So I think that has been a pretty integral part for us to actually solving this jigsaw and making everything come together.
No, very interesting how technology is not the only piece for scaling, but there is a business model innovation that is also required to aid in the scaling part. Sunder, if we can have the slides. No, I think this is for the next session. Can you go back? Yes. So, Sunder, if you can take one of these questions and maybe perhaps talk about it.
So I'll take the second question.
Sure.
What types of partnerships for impact? So typically when we look at alternates to plastics, I mean, I would say plastics are just so much on our face right now. Everyone is talking about, the challenges with plastics. And there are a lot of technologies available in the market today which can help provide direction to that whole ecosystem of what is an alternate. In this, what I've personally understood is that when I'm looking at, let's say, a technology of bioplastics, it's many times we all tend to believe that, this is kind of a silver bullet as far as a solution is concerned. Now, when I take my bioplastics technology and let's say I partner it with a product like paper, for example, then I am able to bring out a completely new product which has a lot of value that paper provides as well as the bioplastic component provides. So one of my personal learnings has been that partnership is extremely critical in this journey. There is no one solution which is going to solve this problem. And more importantly, when we talk of plastics, and as Amit said, the moment it goes into a post-consumer waste stream, you're never going to get a plastic as a plastic. It's always going to be a part of another waste stream. So you're not looking at the problem on a standalone basis. You're looking at a problem holistically, where what do you do with it along with the other waste? Now here is where partnership comes in, because now it's no longer a plastic waste management problem. It becomes a solid waste management problem. So I think what I would really like to say is that we have to be very open in terms of collaboration. We have to be very open with other companies who essentially bring in technologies. There is no single solution to this problem. Technologies will have to coexist in the market, and that really is the way forward. That's what I truly believe in. Yeah.
Wonderful. Thank you so much, Sunder. I think we have a couple more minutes, but I would like to, just for folks in the audience, take comments from all three of you on if someone is to be starting out working on the material space today, with all the years of experience that you have gained, what would you suggest maybe one or two things that they should look out for or pay more attention to? Maybe if we can begin with Dr. Pillai.
So, I would say the number one thing, of course, is to be very clear about the solution you are offering. Do we have a value proposition which is attractive? As I mentioned yesterday, no customer wants to pay anything extra for something which is environmentally safe, or it is going to help mitigate carbon. So nobody is wanting to pay anything extra. So be clear about, if you want to succeed in business as a startup, be clear about the solution you are offering is economically competitive. It is going to be as good as or cheaper than the option which the customer is using today. And look at everything as a bonus. Then you will succeed. Otherwise you will struggle, because acquiring customer, remember, there are so many other service providers today who are already servicing the customer. And they are not going to shift from them unless there is a economic reason for them to shift. Of course, regulatory pressures and other kinds of pressures are coming in slowly. But even today, even after having acquired 300 customers, when I go to the next customer, the decision is always economical. So the one advice, if I want to give to all those who are starting out, be clear that your value proposition is attractive for the customer, from the customer's point of view, and the unit economics is favorable for you to make some money out of it. Otherwise, you'll run out of money sometime or the other.
Wonderful. Very useful. Thank you. Thank you, Dr. Pillai. Amit, maybe if you want to.
Actually, I feel there is no one thing. And, that's actually, you have to embrace the uncertainty of putting things together. And you can look at some things. I mean, if we go back and look at our story, and we've been in works about 10 years now, and so in some ways, I think it's like there is an unpredictability and an uncertainty about how the future is going to forge and come together. But that said, that doesn't mean that you shouldn't have your own predictions. In fact, I would say the segment that you're working with, or you're choosing to work with based on your own maybe academic background or experience of your work and professional life, try to maximize the number of conversations you can have with subject matter experts in your field, be it with studying research papers, going out with and engaging with academia with that in that particular segment. But also very importantly, and I think that would be a very advantageous situation to find oneself in, if one can have a potential customer who could potentially at some point of time become a customer, be somebody who you can start or potentially have at the earliest point feasible in your journey. So that's very helpful, because they can really help you calibrate your journey and make sure that you're not running down into rabbit holes, which is entirely feasible, entirely possible, should be expected. And the journey itself requires calibrations and recalibrations. So I would say that if you can, the earlier you can get even tentative, you don't even need to use the word partnerships, as long as you can have evangelists who are who are saying, hey, you are working on something that we feel is important. We are willing to bring our subject matter expertise of what as a company we think about it. And then all of the things that Sir said over here will come into play, because they'll ask you to force you to look at economics with a keen, precise eye and make sure you're able to deliver them within the cost metrics that the market is going to support. So that's there. But, I think there is just tremendous value to get started. It's really hard. I mean, everybody, when they start, they have, if we go back and think about the set of projections we had, we were looking at building the tech in 3 to 4 years. We were looking at markets inflecting in a certain direction. So timing is not something that is, my sense is that entrepreneurs, there is things that are given to entrepreneurial energy, and that's actually a whole lot of things. It's not to be undermined. But then there should also be this very polite and humble recognition that there are some total of things that you have very little influence on, and markets being the key of them. So I think timing is critical, but staying the course so that the timing can actually start becoming in your favor is probably even more important. So the sum total, I mean, this is actually one of, IIT Madras is increasingly perceived and very validly so as being a crucible for some of the best startups we are especially seeing in climate tech and hardware tech, in solving some of the best problems or the leading problems of our times. And I think there is just value in, you already have the ecosystem of support here, which is so much lacking the moment you step out of this place. So I would say that this institute and those who are affiliated or associated with it are in a good stead, and just get started and allow the rest of the story to unfold. So that would be my 2 bit.
Okay. Thank you, Amit. Sunder, maybe from your end.
So typically when we are looking at any new technology, especially in the sustainable space, and I think Dr. Pillai would second this a lot, like it's the customer expectation is it has to be at the same cost or probably lower, and it should be more sustainable than what we have today. So that's the starting expectation from the customer. I mean, no one wants to pay anything more, however sustainable it is. This is the hard reality. Then how do you get to that? Because you're probably starting off with a technology which is not as evolved as what is already existing from a process perspective, from a scale perspective. So you are already starting at a point where the costs are going to be higher. One approach that I've used is, can we find value to your product and technology that is over and above what you're actually giving? So can you look at your solution as a way to engineer a certain system, in the sense, if I'm replacing apples to apple here, but then in that replacement, can I add some other value by which I can cover my additional costs? Okay, so I'll give you an example here. When we started off, one of our first customers was Levi's, and we were looking at a very simple concept. So Levi's kind of packages all their garments into plastic bags, and these garments are made in countries like India, Sri Lanka, and they're exported out. So when we gave a solution which is the replacement to this plastic bag with a bioplastic, the price of our product was almost 55-60% higher than the conventional plastic. So Levi's was like, let's see what we can do together. So we started off by a simple exercise of saying that, okay, today you're using a certain thickness of the bag. Do you really need that thickness? I mean, what was the mentality in even getting into that thickness? So can we start reducing the thickness? So that was one re-engineering we did to say, okay, let's reduce the thickness without compromising the functionality of the why that product needs to be used. The second thing we did was, for certain segments of non-crease kind of shirts, simple tees and stuff like that, we did a very small packaging shift. So they used to take the shirt and place it flat. All that we did was we made one fold to the shirt. And what that did was that reduced the size of the bag by half. So what I'm saying here is, there's no sometimes thinking out of the box in being able to engineer a solution, and we get very hung up on our product, but I think our product would start making sense provided it kind of aligns with some of these other things in the ecosystem. And then thankfully, when we started in 2014, the cost at which we are doing then to what we are doing today, we are much lower. So we just need an entry. We need something to go forward. And it's that belief that we can do it. So cost is always going to be there. I don't think you're ever going to, I mean, if you have the lowest cost product and the most sustainable, then that's great, but it's never that case. So I think we got to think out of the box here. really.
Sure, please.
So, yesterday, just before lunch, we had a session it was called the Titanic session, right? We talked about Professor Junjunwala in his presentation said the change management, that is, if you really want to achieve the goal of, let's say, net zero or keep the increase in temperature below 2 degrees, etc., the idea should get implemented. There will be hurdles for that. That's the point he made. And I spoke yesterday just before lunch saying, make your solutions cheaper than what the oil companies or the ones who are creating the problem today are providing to the customers. We saw many examples yesterday, including the report which was presented by Professor Junjunwala, that adopting technologies which are low in emission is going to be cheaper, right? He showed a cost saving of something like, if I remember correctly, 15% lesser than taking the energy from the grid. So, I believe the future objectives of this net zero will be achieved by technologies which will provide solutions at a cheaper cost than what is available today. And I think it will happen. I'm a optimist. Of course, all entrepreneurs are optimists. I believe that the solutions which are coming out in various fields is going to make sure over the next maybe 2 or 3 decades, I may not be alive, but they will reach a stage where they will be cheaper than the ones which are creating the problems today. And then therefore, my grandchild will live in a cleaner world.
Wonderful. Gentlemen, thank you so much. I would love to continue picking your brains, but we're running short of time. But the last points that all three of them mentioned, thinking of unit economics, adding value to the customer, adding value plus as well, and thinking out of the box, and also looking at initial customers who can validate and be along with you as you build the product. Some useful things for all of us to ponder upon as as entrepreneurs and as investors for us to think about when we look at startups. Thank you so much, gentlemen. I hope all of you had something to take away from the session. I believe all of them will be there for the rest of the day as well. So will I and my colleague Nitish as well. Happy to have a chat with any of you. Please do reach out to us if you have something. Thank you very much. Thank you.
I would like to request the speakers to stand together for a group photograph.